Good morning, guys. I'm Nishan Dinesh Nambiar. You are putting CS241. Today I'm going to do my Unix lab experiment number 8. Uh, so here I have three programs to do. So my first process, my first program is to show how many seconds an hour, how many minutes and hours does a seconds have. So the program for that is given here. So hint seconds, minutes, hours, printf parent process, get PD, then printf enter the seconds, the scanf the user inputs the seconds, int PID is equals to fork. So now I'm creating a fork here. If fork is equal to 0, printf child process, printf parent ID. So and a child process is created. Fork is used to create a child process. So and a child process is created, and printf parent ID get PPID. So for get PPID, we'll get the parent ID. Int hours is equals to seconds. For 1 hour is equal to 3600 seconds. 1 minute is equal minutes is equals to seconds modulus 3600 divided by 60, and seconds is equals to minute percentage 60 divided by 60. So printf hours minutes seconds is sleep for 2 seconds. So let's look at the output for this. So I am entering 5800 seconds. So the child process ID is 12588, parent ID is 12587. So for 4800 seconds, that is 1 hour and 36 minutes. So that is my first program. Let's look at the second program. So my second program is to show that whether it's a palindrome or not, and I will enter the string, and I can even print the reverse of the string. So the program for this is, first I have initialized all the hash files. So printf parent process, printf enter the string, the user enters the strings. So I'm initializing string length. So on object L is equals to string dot length string. So this gives us the length of the string. Printf string length is given here. Then int PID is PID equal to 4. So now I'm creating a fork here. So a child processor is created. So now we can here the child processor is created. Now I can even print the parent ID, get PPID, then for loop for I is equals to 1, I greater or equal to 0, I plus plus. Then the reverse of the string is created. Now I need to check whether it's a palindrome or not. So for I equal to 1, I less than or I greater or equal to 0. So string j plus plus is equals to string minus minus I. So string concatenation string CMP. Now let's look at the output. enter the string. So the length of the string is given here, then the reverse of the string, then the string is not in a palindrome. Now let's look at the next program. So this is my next program. Here an integer is integer is given as an input. We need to find the factorial, whether it is in a prime number or not, the Fibonacci series. So the program for this is printf init parent process a with id. So scanf, we are taking the input. Now I am creating creating a child process. PID is equals to fork. So process B is created, and the parent ID we can input. Parent ID is given through get PID. So for the factorial, int a is equals to n, x is equals to a. Then while then we are creating a while loop, x minus 2 greater than 0. So print percentage d comma d gives us whether the palindrome. Then else sleep for 5 seconds. Now int PID2 equal to fork. Now I am creating another process. So process C is created, and the parent ID is given. Parent ID is inputted. So this is to check whether it's an Armstrong or not. So for that, for checking whether it's Armstrong, is res plus r into r. So we need the given input should multiply into 3 times. So printf percentage d is an Armstrong number, percentage d not an Armstrong number. Now it is whether to check whether it is a prime number or not. For I equal to 1, I less than or equal to n, I plus plus. If I n percentage I equal to 0, C plus plus. If C equal to 2, if C is equal to 2, then print it is a prime number. Percentage d is not a prime number. So int p5 is equals to 4. So I am creating a new process here. So process f is created. So process f is created. Now I need to find the reverse of the given integer. So int a equal to n, int e is equals to a, re is equals to 0 mo, while e is greater than 0. So now let's look at the output. Enter an integer. I am entering an so child process, first child process A, first child process B is created. So the factorial of 6 is 720. Then a process D is created, that shows the Fibonacci series for 6. Then a process C is created, that shows whether it's an Armstrong number or not. 6 is not an Armstrong number. Process E is created, whether it's a prime number or not. 6 is not a prime number. Process F is created, then reverse of 6 is 6. So that's all. Thank you.